Newton's Three Laws of Motion by Justin Hernandez, Harrison Hess, and Hunter O'Brien.
Newton's first law of motion explains that still objects will stay still while moving objects will keep on moving. The exception to this idea is only when forces are unbalanced. For example, when I push this box without letting go, it keeps a constant speed and direction. The forces are balanced, meaning there is no net force. Gravity counters normal force and applied force counters friction. However, if I push the box and let go, it slows down. There is no force countering friction, so the forces are unbalanced, meaning there is a net force.
Newton's second law of motion. Newton's second law of motion explains how force and mass affect the acceleration of an object. If the force increases, the acceleration increases. This is known as a direct relationship. If the mass increases, the acceleration decreases. We call this an inverse relationship. For this problem, we're trying to find the net force of a 4 kilogram pool ball accelerating at a rate of 2 meters per second squared, and the net force of a 1 kilogram ping pong ball accelerating at a rate of 8 meters per second squared. To find the net force, we can use the equation F net equals mass times acceleration. Since we have the mass and acceleration, we can plug those into the equation and easily find the net force. For the pool ball, F net equals 4 kilograms times 2 meters per second squared. Therefore, F net equals 8 newtons. We also have the mass and acceleration for the ping pong ball, so we plug those into the equation as well. F net equals 1 kilogram times 8 meters per second squared. The answer is also 8 newtons, which means that the balls have the same net force.
Newton's third law of motion. Newton's third law of motion explains how each action has an equal and opposite reaction. For example, when you stand on the ground, you push on the ground. The equal and opposite reaction is the ground pushing you. The cards in this video show that no matter the situation, the springs push off each other with the same amount of room. This means they exert the same force on each other. Thank you for your time. We wanted to use a quote by Albert Einstein from his book The World as I See It. The most beautiful experience we can have is the mysterious. It is the fundamental emotion that stands at the cradle of true art and true science.